So we've been given questions to predict the direction and EMF of these redox reactions. We have been given two different half cells that we're going to combine together to make an electrochemical cell, and we want to know which direction the electrons are going to flow. What reaction overall is going to happen between these two half cells. Okay, so we've got the aluminium half cell and a chlorine half cell, and their standard electrode potentials are minus 1.66 volts and plus 1.36 volts. What we're going to do to predict the direction and the overall reaction in this electrochemical cell is we're going to use that diagram we looked at in the previous slide. So what we're going to do is we're going to start by drawing our 0 volt line. So we're going to draw the line that represents 0 volts. We're then going to draw the two half cells represented by a line depending on where they are, okay, so compared to 0 volts. So the aluminium half cell is minus 1.66 volts. So I'm going to put my aluminium half cell to the left, and I'm going to draw an arrow to say that that's minus 1.66. My chlorine is plus 1.36 volts, so I'm going to draw that to the right hand side of my 0 line, and I'm going to say that that is plus 1.36. Okay, this is just a visual representation of the numbers. Now we know that electrons always flow from the place of negative potential to the positive. So I'm going to draw a line in a different color to represent the movement of electrons from the more negative potential to the more positive potential. So even just by drawing this diagram, we know that electrons are going to flow from the aluminium half cell to the chlorine half cell, okay, and that's half the work done. Now we need to write out the overall redox reaction for this process by adding up the two half equations. So we need to write the two half equations to make the whole equation. So let's start with the aluminium one. We always start with the one that is originating where the electrons are going to originate from. So the aluminium redox reaction that you will see in tables is going to be the reduction reaction. So it's going to be like this. Aluminium solid, and that is minus 1.66 volts. That's the electrode potential. Now let's have a think about this. In this overall electrochemical cell, aluminium is getting oxidized. The electrons are leaving this half cell and going to chlorine. So aluminium is going to get oxidized. That means we need to reverse this process. So we reverse the half cell with the more negative potential. So I'm going to reverse this process. So go aluminium 3 plus AQ 3 minus. Because we've reversed this equilibrium, the sign is going to change on my electrode potential, so it's going to go to plus 1.66 volts. So this is the reaction that's going to be happening on the left-hand side. The one on the right-hand side is going to be chlorine accepting electrons to form chloride, and so that is what we call the reduction potential. So that's going to be chlorine. It's going to accept electrons to become chloride. And we know from the table that that is plus 1.36 volts. Now we haven't reversed this reaction. This is the equilibrium. This is the direction that is written in our standard electrode potential tables. And so we keep the sign the same. And so to calculate the overall EMF of this reaction, we've done the hard work. Now we just add them up. So 1.36 plus 1.66. Okay, and that is equal to plus 3.02